The abstract factory pattern provides an interface for creating families of objects without specifying what their concrete types are. It should be used when there is a system that creates objects, but how those objects are created should be hidden from view. In particular, it is used when applications have families of objects. The application should be able to choose which of a selection of families it wants to use. The abstract factory pattern can ensure that family groups are used together. Say, for example, there is an application that builds bicycles. First, all of the individual bike parts need to be built. The wheels, handlebars, gear, and frame and so on need to be made. And not just any old parts. To make a mountain bike, for example, you need wheels with a strong frame and thick tyres. Mountain bikes also need straight handlebars. So these different parts are examples of a family of objects that need to be made together. The process of making a mountain bike is different to making a road bike, which has different wheels, gears, handlebars, and so on. It would be wrong to mix up any of the parts for the two bikes. If the road bike had a mountain bike wheel, it would not work very well. Both types of bikes have the same kinds of parts, i.e. they both have wheels, but the actual parts themselves are different. This can be complex when it comes to representing a bike builder in Java code. A constraint of a bike builder class is that it does not want to hardcode the parts when a specific bike is built. This would be inflexible and lead to long and complex code all in one place. If any changes needed to be made to how a specific type of bike part is built, this code would need to change again. The bike builder shouldn't need to care about how the bike parts are built. It just wants to ask for the bike parts and be given them. The abstract factory pattern solves this problem by providing an interface for making different types of bikes. In this case, there would be an interface called Bike Factory, which has two concrete implementations, Mountain Bike Factory and Road Bike Factory. A Mountain Bike Factory would return a mountain bike wheel, which is a concrete implementation of a wheel interface. And a Road Bike Factory would return a road bike wheel, which is another concrete implementation of wheel. This way, the bike builder does not need to know about how the different parts are made, because the concrete classes are isolated from it. It also promotes consistency. If the bike builder is using a mountain bike factory class, it cannot create any parts other than a mountain bike part. If it asks for a wheel, a mountain bike wheel is created and returned. There is no need to specify that a mountain bike wheel is needed, because the abstract factory already knows and deals with that. This is a much better way to structure the code. In this example, there is an application that builds bikes, and that uses the abstract factory pattern. However, as the application gets more complex, the abstract factory becomes more complex too. The factory creator class has a method called createFactory, and this takes the type of bike needed as a parameter. If mountain bike is passed in, it will return a mountain bike factory that can create mountain bike parts. And if road bike is passed in, it will return a road bike factory that can create road bike parts. These factories both extend an abstract class called Bike Factory. If I open the Bike Factory class, it has two methods called createTyre and createHandlebar. Obviously, in reality, more than just tyres and a handlebar are needed to make a bike. There will also need to be brakes, gears, a saddle, pedals, and so on. There might also be other types of bike that need to be created, besides mountain bikes and road bikes. A more complete version of the application might have a class called Saddle, so I would need to add a createSaddle method to the Bike Factory class. But I would also need to implement this abstract method in the other factory classes that extend Bike Factory, including Mountain Bike Factory and Road Bike Factory, and any other types of bike factory that I might want to add in the future. So I would need to go through and add the createSaddle method to all of the classes that extend Bike Factory. That is a lot of places where new code needs to be added, especially if more bike types are added, and I would need to do this for every single new part that needs to be created. The solution to this problem is to remove all of the methods to create individual parts and have a single create method. This method would take a parameter that identifies which kind of bike part is being made, and return that part. This will make the code much more flexible. Instead of having a separate method for creating every single part, only one is needed. However, although this approach is more flexible, it is also slightly more risky, especially in statically typed languages like Java. It would only work if all bike parts extend the same abstract class. In this example, the Bike Builder application shows how the abstract factory pattern can be used. The application builds bike parts either for mountain bikes or road bikes. First of all, there are a couple of abstract classes called tyre and handlebar. These are parts of the bike, and they are abstract because different types of bike will have different concrete implementations. They both have one abstract method, getDescription. Then there are two more classes called mountain bike tyre and road bike tyre. These are the concrete implementations of the abstract tyre class. Both mountain bike tyre and road bike tyre provide implementations of the getDescription method. These are slightly different because the mountain bike tyre class prints out both the width and the pressure. Road bike tyre only prints out the width. There are also two classes called mountain bike handlebar and road bike handlebar. These are concrete classes that extend the handlebar class. Mountain bike handlebars are straight, while road bike handlebars are drop handlebars. Next, there is an abstract class called Bike Factory. This declares two methods, create tyre and create handlebar. This method is implemented by the two concrete classes that extend the Bike Factory class, Mountain Bike Factory and Road Bike Factory. The Mountain Bike Factory returns a mountain bike tyre and a mountain bike handlebar, while the Road Bike Factory returns a road bike tyre and a road bike handlebar. Next, there is a class called Factory Creator. This class has one method, create factory. Create factory takes an argument of type string, and this is the type of bike that needs to be created. If the argument passed in is mountain bike, a mountain bike factory will be returned. If a road bike factory is created, a road bike will be returned. And the final class is Bike Builder. This is the class that collects the bike parts to build a bike. It currently has two methods, create bike without abstract factory and create bike with abstract factory, plus a main method. Create bike without abstract factory shows what the code would look like if the abstract factory pattern was not used, while create bike with abstract factory shows what it looks like when the factories are used. Create bike with abstract factory takes a string parameter, which is used to determine which type of bike to make. The main method calls both of these methods. For the create bike with abstract factory method, it specifies a mountain bike as the type of bike to create. If I run the application, the output shows that both the methods do exactly the same thing. They both create two mountain bike tyres and a mountain bike handlebar and print out their descriptions. However, in a method that does not use the factories, the code has to be specific about what type of tyre it creates, and use the concrete type. If I changed my mind and decided I wanted this method to return a road bike instead of a mountain bike, I would have to completely rewrite this. Every time a mountain bike tyre is made, I would have to change it to road bike tyre. And when a mountain bike handlebar is made, I would have to change it to road bike handlebar. In contrast, if I want to use the create bike with abstract factory to make a road bike, it is very simple. All I would have to do is change the argument I pass in the main method. If I change mountain to road, it will make the parts for a road bike. If I run the application again, the output shows that with one simple change, I have used the create bike with abstract factory method to make a road bike. Using this method, there is no point where the concrete types of the bike parts are specified. The code is nicely decoupled and the details are abstracted from the Bike Builder class. This is a much better implementation than the create bike without abstract factory method. In this example, the Bike Builder application has been rewritten to be more extensible. It is now easier to add bike parts to the application without having to alter code in several different places. The first difference is that a new class has been added. This is an abstract class called BikePart. It declares a single abstract method called getDescription. This class is extended by the tyre class and the handlebar class. Then, the bike-specific classes still extend these. For example, the mountain bike handlebar class extends the handlebar class, and the handlebar class extends the bike part class. So all of the specific bike part classes, mountain bike handlebar, road bike handlebar, mountain bike tyre, and road bike tyre, all extend classes that extend bike parts. The reason they all extend the same abstract class is because this then means that the create methods can be combined into one. Inside the bike factory class, there is now only a single method. This avoids the necessity to create a method for both the different bike parts. Any more bike parts that need to be created would have to be added here as well as in every factory that extends bike factory. Now, however, handlebar and tyre both extend the bike part class, so it is possible to have a single create method that can return any kind of bike part. The method takes an argument of type string that identifies which part should be returned. In the concrete classes that extend bike factory, there are if statements to determine which part to return based on the string. In mountain bike factory, if the argument passed in is tyre, then it returns a mountain bike tyre. If it is handlebar, it returns a mountain bike handlebar. In road bike factory, if the type is tyre, then it returns a road bike tyre. And if it is handlebar, then it returns a road bike handlebar. If a new bike part needs to be added at this point, there is no need to create a new method. All that needs to be done is to add it to the if statement in the appropriate factory class. For example, if there was a class called mountain bike mudguard, another if-else could be added to the create method in the mountain bike factory class. It would say that if the type equals mudguard, then return a new mountain bike mudguard. There would be no need to have a whole new method for it. The final change is in the bike builder class. There is now a method in this class called createBike with extensible abstract factory. It still creates a bike factory of the type passed into it. It then creates a bike tyre. However, the variable that is declared has to be cast to its type when the create method is used. For example, when a variable of type tyre is declared and assigned to the result of the create method, this has to be cast to tyre. This is because the return type of the create method is bike part, not tyre. This is slightly less safe than the previous example, because the bike builder class is being relied on to know that the type being returned is a tyre. This is the trade-off that has to be made with extensible factories. It is now much easier to add bike parts, but more reliance is placed on the bike builder to return the correct types. Whether this method should be used depends on the situation, but in general, it is a useful way to make the abstract factory extensible.